Welcome to this course on DNS and bind. DNS is one of the cornerstone protocols making up the internet. Today, most modern network engineers are expected to have a thorough understanding of how DNS works, since it is the first thing that happens on the network before the actual application traffic is initiated. If there was such a thing as a full stack network engineer, then DNS would be definitely on that list. Now, I have designed this course for any IT professional or student wishing to learn DNS and bind all the way to the expert level. By expert level, I mean by the end of the course, you will be able to troubleshoot complex DNS issues such as the ones handled by engineers at Google, Facebook, Cloudflare, AWS, etc. So what are we going to learn in this course? This course is dedicated to the working of the DNS protocol and also to bind, which is one of the most popular DNS servers. We will deep dive into the protocol's RFC and how it works under the hood to provide different types of DNS services to clients. We will also learn how to set up a DNS server using bind and make it production ready as both a recursive resolver and an authoritative name server. In the first few modules, we will cover different components of the DNS system, that is the hierarchical DNS namespace, what is a DNS domain versus what is a hosted zone, forward versus reverse zones, resource records, concept of delegation, the root and top level domain name servers on the internet, the difference between resolvers and authoritative name servers, iterative versus recursive queries, and related concepts. Then we go into specific types of resource records like A, Quad A, CNAME, SOA, NS, CAA, PTR, SRV, TXT, etc. Their purpose, how to use them, and the rules and limitations which govern them. We will also touch upon wildcard records and specific scenarios related to them. In Module 3 and 4, I will introduce you to the lab and the DNS packet format. I will explain different DNS flags, different DNS response codes in the DNS header, and show how to interact with the DNS system using DIG and NSLOOKUP. These lessons are filled with several examples on how to query resolvers, authoritative name servers, and thoroughly interpret all the different sections in the output, that is headers, query, answers, authority, additional and statistics sections. In Module 5, I will then connect all the dots and deep dive into the entire DNS resolution process, what happens on the end clients as soon as you enter a URL on the browser, different files and operating system programs that are invoked before the operating system sends out a DNS query on the wire. How does a resolver query the root, the top-level domain, and the authoritative name servers to answer the client's query? How does this process differ when we have white-label name servers in the picture? What is the role of glue records? How do end-client applications and operating system cache DNS answers? How do resolvers cache DNS answers? Do they cache referrals? I will then go on to show how is dig plus trace different from normal recursion, highlighting the difference between how a client consumes a referral versus how a resolver consumes a referral. In Module 6, we shift gears and start working with bind. We will learn how to set up a recursive resolver, how to tune the resolver properly to address a wide variety of situations and requirements, how to verify the server's operations using RNDC, logs, statistics, cache files, packet captures, etc. I will explore dozens of settings which are used on production DNS servers facing the internet. Next, we learn how to turn the resolver into a caching-only server by only forwarding queries instead of performing recursion. Next, I will show how to set up authoritative master and slave name servers and explain how to format the zone file and how to tweak a ton of different zone-related settings and how zone transfers work between a master and slave name server. We also discuss several settings which can be used to tune and optimize the zone transfer operation. Next, I show a complete end-to-end walkthrough of buying a domain from a registrar and how to set up your own custom branded name servers. I will cover the things you should consider before purchasing a domain from any registrar, the process of purchasing a domain from a registrar, how to use the registrar's DNS hosted zone service, and then how to set up your own internet-facing branded DNS server instead of using the registrar's DNS service. This module also covers examples of different real-life architectures used in large networks which operate hundreds of DNS servers. There is also a lesson which covers how to perform subdomain delegation. In Module 7, we deep dive into the DNS protocol and explore several advanced concepts, starting with how different settings on end clients like timeouts, retries, multiple DNS servers, end dots, suffix lists can cause different behaviors. We then cover a very key concept, that is extension mechanisms for DNS or eDNS, and how it works on a per hop basis, and what to expect with the default settings related to eDNS on your bind server. We will also practically see how eDNS affects the way large DNS packets are exchanged between DNS servers or between the client and the DNS server, and also how to tweak these settings for different situations. Next, we cover split DNS or views and its use case and how to set up this feature on the bind server. Then we go into some more advanced features like ECS or eDNS client subnet, which can be used to force resolution based on actual client IP rather than the resolver's IP. And so this feature can be used to open up different DNS routing policies based on the end client's IP. The same lesson will also cover the concept of name server identifier or NSID, which is a cool feature which can be used to identify a DNS server uniquely in an Anycast cluster. Next, we cover DDNS or dynamic DNS updates, its purpose and use case, and how to set this up safely on the bind server. Final lesson in this module will cover how to perform classless reverse delegation. Module 8 is all about DNS security. We explore a number of different attacks such as cache poisoning attacks, reflection and amplification attacks, and learning how to configure different features on the bind server to protect and harden the server from these attacks. We look at DNSSEC in detail, how the whole chain of trust is built to validate the integrity of the DNS response. We learn how to work with DNSSEC related records and related settings on the resolver, how the whole resolution works with DNSSEC in the picture, different DNSSEC failure scenarios, and then finally how to set up, verify, and maintain DNSSEC on bind, including key maintenance. In the DNS firewall lesson, we see how to set up response policy zones on bind and see different types of firewall rules in actions and configure a live threat feed. Next, we explore various rate limiting and response filtering features like RRL, black hole, and NX domain redirection. We will also explore new transport mechanisms for DNS, such as DNS over HTTPS and DNS over TLS, and learn about the protection these features offer. The last lesson in this module, we look at how DNS cookies work, how they provide protection against cache poisoning, reflection, amplification attacks, and how to make cookie-related settings on the bind server. The last module of the course is dedicated to troubleshooting, starting with whois lookups to verify domain status, checking EPP status codes, and then I show you some real-life DNS issues which I got to troubleshoot over the years working for some large corporate organizations with complex DNS environments. I also show how to build your troubleshooting approach and how to work on narrowing down the issue and different techniques to solve them. The module also has a lesson on how to run load tests on DNS servers and observe what happens when a bind server is under heavy query volume load. In the bonus section, I demonstrate the basic use of systemd resolved and DNS mask, which are popular caching stub resolver programs for Linux clients. Now here is the lab we are going to use in this course. It is running on Eve NG Pro, which is a great simulator just like GNS3. We've got a few Linux Ubuntu servers in the lab. We will install and configure bind on this server in Data Center 1 and configure it as a resolver. As we progress in this course, we will learn how to set up the server as a forwarder and also an authoritative name server. I will use this Ubuntu server as a slave authoritative server and show zone transfers. I will also set up another DNS server facing the internet here in both the DMZs, so this one and this one here, to host our public hosted zone. There are other DNS servers in this lab as well, such as this Infoblox server in the data center environment and also in the DMZ environments. These will be used to demonstrate how large corporates set up their DNS architecture. Alright, so here are the full table of contents in each lesson. You can download this from the course resource section and use it to navigate through the course. To fully appreciate the course, you should have basic networking and Linux knowledge, access to a few Linux servers. They could be on cloud, Eve NG, GNS3, access to intermediate network devices such as routers, switches, and firewalls. Even if you just have access to a Linux server, it should be good enough to learn the core concepts presented in this course. By the end of this course, I guarantee that you will have the confidence to answer DNS-related questions in interviews with top technology companies and be able to solve the most complex of DNS issues. If you need any support or have any feedback or query, please feel free to send an email to support@ultimatenetworkwarrior.com. Thank you for watching, and I look forward to see you in the course.